My name is Herrera. I am a GEARUP tutor for Rio Bravo Middle School. I am going to be introducing some algebra concepts to help you prepare for Algebra 1. But why is algebra so important, you may ask? It is important because formulas become a part of our everyday lives. Whether we drive a car and need to calculate the distance, or need to work out the volume in a milk container, algebraic formulas are used every day without you even realizing it. Furthermore, for most, if not all of you, will need to know how these basics for your high school years, college, and even your future jobs. You will use math even if you think you won't. So let's not waste any more time and get right into it. We're going to be going over an introduction to geometric sequences. So, what are geometric sequences? Geometric sequences. Going off of what we learned about sequences and arithmetic sequences from my peers, we can derive the following definition. A geometric sequence is a sequence of numbers where each term after the first term is found by multiplying the previous one by a fixed non-zero number called the common ratio. So what does this even mean? This means that we will be repetitively multiplying numbers by the constant. So an example, we have the terms 1, 2, 4, 8, 16, 32, and so on. What is the pattern in this situation? Yes, it is 2. The sequence has a factor of 2 between each number. Each term except the first term is found by multiplying the previous term by 2. So to put it visually, we can use the following number line. We will be using the first 5 terms. So 1 times 2 gives you 2. Then 2 times 2 gives you 4. 4 times 2 gives you 8. And 8 times 2 is 16, and so on and so forth. So that's basically how it's done. So going off of that, you must be thinking, there must be an easier way to find this information. Yes, there is. We want to come up with an equation that gives us the nth term. So in general, we write geometric sequences like this. A, AR, AR squared, AR cubed, and so on and so forth. This meaning that A is the first term and R is a factor between the terms called the common ratio. Using this, we can calculate any term using the following rule. You generally start off with the first term, then you're looking for the common ratio, and then your exponent. And this looks as follows. You can further use this formula to extend a given sequence or even find a term. So let's do an example using the rule. We have the following terms: 10, 30, 90, 270, 810, and 2430. We can see that the sequence has a factor of 3 between each number, meaning that 10 times 3 is 30, 30 times 3 is 90, 90 times 3 is 270, and so on and so forth. So let's figure out what our values of A and R are. A is the first term and R is the common ratio. This meaning that A is 10 and R is 3. So remember our formula. When we plug in our A and our R, it will look as follows. A is equal to 10 times 3 exponent n minus 1. Remember that n is the term we are trying to find. Using this, let's try to find the fourth term as an example. We will use the following formula, only replacing n with 4. Then we will solve. So exponents first. So 4 minus 1 is 3. Then exponents again. 3 times 3 gives you 27. Then we would just use simple multiplication. So 10 times 27 is equal to 270. And we know this is correct because we can see it in the above terms. Now let's try to find a term that is not in the list. Let's find the 10th term. Using the same formula, just replace n with 10. Then we do the exponent first. So 10 minus 1 gives us 9. Then we will do 9 times 3, which gives us 19,683. Then we will multiply that by 10, giving us 196,830. So that wasn't too bad once we have the formula. Well, further, geometric sequences not only increase in value, but you can also have smaller and smaller values. We can use the following example to explain this. The terms we have are 4, 2, 1, 0.5, 0.25. With this, we can determine that the factors are decreasing by 0.5, or half of the previous term. Therefore, the rule in this case is an is equal to 4, which is the first term, times 0.5, which is a common ratio, with an exponent n minus 1. Therefore, to figure out more terms in the sequence, you would simply use this formula. But be careful, r should never be 0. When r is 0, we get the sequence a, 0, 0, and it keeps on being 0, which is not geometric at all. Lastly, why do they call it a geometric sequence? It is called this because it is increasing the dimensions in geometry. Overall, geometric sequences are a sequence of numbers where each term after the first term is found by multiplying the previous one by a fixed non-zero number called a common ratio. Further, we found out that we can use the following formula to help us calculate any term in the sequence. And lastly, we found out that geometric sequences can increase and decrease in value, but cannot be 0. Lastly, if you have any more questions, concerns, or just wish to know more, remember that tutor.com is a great, excellent resource that is available to you guys. I am Herrera, and thank you for allowing me to introduce geometric sequences to you. Goodbye.